In this video, we will discuss simple LR or SLR. L is for left to right scanning of the input. R is for constructing a rightmost derivation in reverse. SLR is the easiest method for constructing shift reduce parsers. An LR parser makes shift reduce decisions by maintaining states to keep track of where we are in a pass. States represent sets of items. So a single state can be represented by using a set of items. These items can be we can call as LR0 item. LR0 items of a grammar. An LR0 item of a grammar G is a production of G with a dot at some position of the right hand side. Thus, a production A gives X, Y, Z has 4 items. We can create these items by just putting a dot at different positions. A gives X, Y, Z. So we can create an item by putting a dot here at first position, then another item by putting a dot after this X and before this Y and Z, then another item A gives X, Y dot Z, then A gives X, Y, Z dot. So these are the 4 items that can be generated from the production A gives X, Y, Z, where we are putting the dot. Based on that, we can have different LR0 item. So has 4 items. They are A gives dot X, Y, Z, and A gives X dot Y, Z, then A gives X, Y dot Z, then A gives X, Y, Z dot. Note that production A gives epsilon has 1 item, that is A gives dot. An item indicates how much of a production we have seen at a given point in the parsing process. For example, the item A gives dot XYZ indicates that we hope to see a string derivable from XYZ next on the input. An item A gives X dot YZ indicates that we have just seen on the input a string derivable from X and that we hope next to see a string derivable from YZ. An item A gives XYZ dot indicates that we have seen the body XYZ and that it may be time to reduce XYZ to A. So before explaining the SLR parsing algorithm, we have to consider the canonical LR0 collection. So it is a collection of sets of LR0 items, or it is a set of sets actually. For example, these are some LR0 sets. This corresponds to these are LR0 set because this contains a number of items, item 1, item 2 and item 3. This will form a set. Similarly, this is another set. This contains only a single item, and this is another set that contains 2 items. This is another set, this is another set. All these together, these sets together form another set. This will form our collection of our canonical LR0 collection. Canonical LR0 collection. Canonical LR0 collection. So this will be actually a set of sets. ഇതിനകത്തുള്ള ഓരോ എലമെൻറ്റും വേറൊരു സെറ്റ് ആയിരിക്കും. ഓക്കെ, ആ സെറ്റിനകത്ത് that will contain a number of LR0 items. Okay. So a collection of sets of LR0 items provides the basis for constructing a DFA that is used to make parsing decisions. Such an automaton is called LR0 automaton. Each state of the LR0 automaton represents a set of items in the canonical LR0 collection. So this is an example DFA for shift reduced decisions. So here this is one set of item, and this is another set of item, this is another set of item, like that. And each set of item that will form a state, and by using these different states we can form a DFA. To construct the canonical LR0 collection for a grammar, we define an augmented grammar and two functions, closure and goto. Okay. First we can consider the augmented grammar. If G is a grammar with start symbol yes, then G dash, the augmented grammar for G, is G with a start symbol S dash and production S dash gives yes. The purpose of this new starting production is to indicate to the parser when it should stop parsing and announce acceptance of the input. Acceptance occurs when and only when the parser is about to reduce by S dash gives yes. Next we can discuss the closure operation for LR0 items. Start with the closure of I. Assume that I is a set of items, and then start with the closure of I is equal to I. That is, we will add all the items present within I to closure of I. If A gives alpha dot B beta is a member of closure of I, then for each production B gives gamma in the grammar, add the item B gives dot gamma to closure of I if not already there. But ഇങ്ങനെ ഒരു പ്രൊഡക്ഷൻ, ഇങ്ങനെ ഒരു ഐറ്റം ക്ലോഷർ ഓഫ് ഐക്കകത്ത് ആൾറെഡി ഉണ്ടെങ്കിൽ, ഒരു മെമ്പറായിട്ടുണ്ടെങ്കിൽ എന്ത് ചെയ്യും? ഫോർ ഈച്ച് പ്രൊഡക്ഷൻ ലൈക്ക് ദിസ് ബി ഗീവ്സ് ആൽഫ, അതായത് ഈ ഡോട്ടിന് ശേഷമുള്ള നോൺ ടെർമിനൽ ഏതാണോ അത് ഹെഡ് പൊസിഷനകത്ത് വരുന്ന പ്രൊഡക്ഷൻ. അങ്ങനെയാണെങ്കിൽ എന്ത് ചെയ്യും? നമ്മൾ ഇവിടെ ഒരു ഡോട്ട് ഇട്ട് കൊടുത്തിട്ട് അതിനെ ഇങ്ങനൊരു ഐറ്റം ക്രിയേറ്റ് ചെയ്യും, എന്നിട്ട് ക്ലോഷർ ഓഫ് ഐക്കകത്തോട്ട് ആഡ് ചെയ്യും, അതിനകത്ത് ആൾറെഡി അതില്ലെങ്കിൽ. Okay. Repeat to until no new items can be added. That is the algorithm for computing closure for closure operation for LR0 items. So consider this example. We have a grammar. This is an augmented grammar with E dash is equal to E. That is a new production added here, and this is our complete grammar. Then assume that I is the set of items that contains only a single item, that is E dash gives dot E. So we have to compute the closure of I. Okay. So closure of I, closure of I is equal to we have to first add whatever present within the I, we will add there. That is E dash gives dot E, that we will add. Then because this is an item present within the closure of I, here there is a dot just before the E, so I will consider all the E productions. So this one and this one, by using this rule, second rule. If there is an item A gives alpha dot B beta, then for each production B gives R, അതായത് ഈ നോൺ ടെർമിനൽ ഡോട്ടിന് ശേഷം വരുന്ന നോൺ ടെർമിനൽ വെച്ച് സ്റ്റാർട്ട് ചെയ്യുന്ന ഓരോ പ്രൊഡക്ഷനെയും നമ്മളിങ്ങനെ കൺവേർട്ട് ചെയ്തിട്ട് ഒരു ഐറ്റം ആയിട്ട് ക്ലോഷറിനകത്തോട്ട് ആഡ് ചെയ്യണം. So we have to here after this dot the E non-terminal is E, so we have to consider all the E productions. So this is one and this is another one, and we will add items corresponding to this one. That is E gives dot E plus T dot E plus T. This is one item. അതായത് ഇവിടെ ഇതിൻ്റെ ബോഡിൻ്റെ സ്റ്റാർട്ടിങ്ങിൽ നമ്മൾ എന്ത് ചെയ്യും, ഇതിൻ്റെ ലെഫ്റ്റ് സൈഡിൽ എന്ത് ചെയ്യും, ഈ ലെഫ്റ്റ് മോസ്റ്റ് പൊസിഷനിൽ ഒരു ഡോട്ട് അപ്ലൈ ചെയ്യും. ദെൻ കറസ്പോണ്ടിങ് ടു ദിസ് വൺ, ദിസ് പ്രൊഡക്ഷൻ വിൽ ആഡ് അനദർ ഐറ്റം ഇ ഗീവ്സ് ടി. ഇവിടെ നമ്മളൊരു ഡോട്ട് ഇട്ട് കൊടുക്കും ഇതിൻ്റെ സ്റ്റാർട്ടിങ്ങിൽ, ബോഡിയുടെ സ്റ്റാർട്ടിങ്ങിൽ. Then so now these items are present within the closure of I. So here dot E, but here dot T is there. So in that case what we will do, we will consider all T productions. Now നമ്മുടെ അൽഗോരിതത്തിൽ പറഞ്ഞില്ലേ, repeat to until no new items can be added. അപ്പോൾ ഓരോന്നും കൺസിഡർ ചെയ്യും. അപ്പോൾ ഇവിടെ ഡോട്ട് ടി ഉണ്ട്, അതുകൊണ്ട് എല്ലാ ടി പ്രൊഡക്ഷനും കൺസിഡർ ചെയ്യുമ്പോൾ ദിസ് ഈസ് വൺ ടി പ്രൊഡക്ഷൻ and this is another T production. So we will add them, the items corresponding to them. That is one is T gives dot T star F. This is one item. Then T gives dot F. This is another item. Now in this case there is a dot F, so we have to consider all F production. So what is that? This two, F gives dot E comma F gives dot ID. Now all the items are added. We cannot add further items. So this will form the this set will form the closure of I. Here I contains only a single item, that is E dash gives dot E. So this is how to compute closure of a set of items. Okay.